First one we're going to talk about today, we're going to talk about side angle side and side side side. Okay, it's different properties that have to do with the sides and the angles. First thing I want to talk about that this curriculum does not spend time on is talking about congruent statements. Okay, so it gives us triangle RST. This is not in your notes yet, just follow along. And it talks about triangle X, Y, and Z. Focusing on this congruent statement, let's say we did not have this picture yet. We did not have that picture. If I said angle R is congruent to what? What angle is angle R congruent to? Just looking at this statement right here. Angle X. Why did you pick X? Because it's the first one. Okay. Angle S is congruent to angle Y. Good. Angle T is congruent to angle Z. Does everyone understand how we got those? It's the order that they come in. Okay. So the same thing with sides as we did with the angle. So if I said side RS, what's RS congruent to? X, Y. Yep, it's still the same order. If I said ST is congruent to YZ, and then if I said RT is congruent to XZ. Question, why could I not put ZX? It has to be not necessarily alphabetical order, but it depends how I put that first one. Okay? So they do have to coincide and match up with each other. Now, if we were talking about the picture here, what does the picture tell us? How many facts does the picture give us? Gives us 3 facts, right? It tells us there's a congruent side, there's a congruent angle, and then there's another congruent side. Okay? This is showing the side angle side property. Okay? Side, angle, side, side, angle, side. Do you agree that those 2 triangles are congruent based off of that? Side angle side is a congruence property. So since those 2 triangles show us side angle side, then what does it tell us about everything else? Everything else is also the exact same since it satisfies side angle side. Okay? So looking at your example 1, focusing on the side angle side property, ignore the rigid motion question. Okay? I want you to tell me if these 2 triangles are congruent to each other. The only thing we know is side angle side. Do these 2 triangles prove side angle side? Yes. Do you agree? This one has side angle side, and this one has a corresponding side angle side. So does this hold true? Yep, so these 2 triangles are congruent by side angle side. Okay. When you're giving me answers, you do not have to put yes or no. You can just tell me whatever property goes with it. Okay? If I gave you, if you want to write these down, that'd be great. If I give you 2 other random triangles, okay, and I draw in these 2 symbols. Go ahead and copy that down real quick. Right now, the only property that I've taught you so far is side angle side. Okay? Do these 2 triangles satisfy the side angle side property? Raise your hand if you think yes. Raise your hand if you think no. Raise your hand if you're not sure. Okay, those of you that said no, can you explain why you're correct? Yes, sir.
Because like the tip of the angle, like they're not the same.
Okay. Pay more attention to the symbols that are in the picture.
One is on like the shorter, and then the other one is on the short side.
Okay. Don't pay attention to my pictures. Like how bad they're drawn. Don't pay attention to that. Do you agree this one shows side angle side? Does this one show side angle side? Why not? But I see side angle side here. Right. Okay. What I noticed about this one, yes, there's a side and an angle right next to each other, but if it satisfied side angle side, where would the other side have to be? It would have to be right next to it. Okay, so with these properties, what you have to be careful of is you can't jump around the triangle. Okay, you notice how it skipped this side and this angle? You cannot jump around the triangle. Okay, it's got to go exactly in order. So this does not have enough information to tell us that they are congruent or not. Okay. So just be aware that they have to be in the correct order in order to satisfy the property. Okay. Let's look at example 2. Okay. On example 1, we were talking about two triangles. Okay, what I want to show you here is that you can split up the two triangles by whatever they're connected to, just like they did in this picture here. They were connected at side BD, so they can split them up into two different triangles. Well, what do I know about these two sides right here? They're the same, right? So we can assume that those connected sides are the same. Okay, so let's take that and look at triangles that are separated, right? What do you notice on number 2? They're together. 2. What are they connected by? AC. So what do we know about AC? It's going to be the same. So I'm going to put congruent symbols in there. If they're connected, we can make these assumptions. Okay? If you ever see this sign right here, what does that mean? It means parallel, right? When you see that in a picture, it's those two arrows that tell us those two lines are parallel to each other. Okay? And then what does this symbol mean? Congruent, okay, and it already put those in there for us. It wants us to know, or it wants us to see if angle B and angle D are congruent to each other. So let's pick this apart. The only thing I've taught you so far is what? Side, angle, side. Can we prove that these two triangles are congruent by side, angle, side? Looking at the picture, do we have an angle that is marked yet as congruent? Can we mark an angle that's congruent? Where? Which ones? A and C, are you talking about these ones right here? Okay, why can we mark those ones as congruent to each other? Right, you know the two sides are congruent and the parallel kind of gives it away. If two lines are parallel, that means their corresponding angles are the same. Okay, remember the transversals? Alternate interior. Remember that from a while ago? Okay, that's why we can assume those two angles are congruent to each other. So, by side, angle, side, do these two triangles satisfy that? Yes. So these two triangles are congruent by side, angle, side. So what does that tell us about angle B and angle D? They're the same. Yep. Then since we know they're congruent by side, angle, side, we can assume that everything else is congruent to each other. Okay. What else can we assume is congruent to each other? Anything else in the triangle, right? What's AD going to be congruent to? BC. What is this angle going to be congruent to? Yep, that top left one. Yep. Okay, so if you ever get one of the properties to be satisfied, you can assume everything else is congruent in that triangle. Okay? Good. Go ahead, flip your notes. Let's look at example 3. Now we're talking about side, side, side. Okay, looking at this picture right here, what do you notice about those two triangles? Why is side, side, side easier to see? Right, because all the sides, it just shows symbols on the sides. So do we know anything about the angles right now? No. So this side has a corresponding congruent side. So does this one, and so does this one. So this would satisfy side, side, side. Okay, you're going to learn to know that side, side, side is your favorite one. Okay, looking at example 3, don't pay attention to the rigid motion part, but do these two triangles satisfy side, side, side? They do. Okay, I want to ask you why. Why do those satisfy side, side, side? What'd you say? No, say it. You got it. Yeah. Right. They all have a corresponding congruent side. This side has a corresponding congruent side on the other triangle, as do the second and the third. Okay, so this satisfies side, side, side. So what do I know about all the angles then? All the angles are going to have a corresponding angle on the other triangle. Good. Looking at this real quick before we jump to example 4. Do we agree that example 1 right here is side, side, side? Does it satisfy the side, side, side criterion? Yes. Okay. Does number 2 satisfy the side, angle, side? That one's kind of harder to see. What do you have to make sure of? The angles in between the sides, and they're directly right next to each other. Okay, so I agree this one is satisfied. I'm going to skip number 3 for now. Let's look at number 4. Does this one satisfy side angle side? Yes, they do. Yep. The side angle side. This angle is in between the two sides. Okay. Looking at number 3. What one out of side, 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 and side angle side would be possible? On this one right here. We have a side, angle, and a side. So people would argue that side, angle, side is the property for those. Why are a lot of you shaking your head? Right. It jumps around the triangle. It skips this whole part right here. Remember, you cannot do that. Okay, so it is okay to put, I always put NA, or you can put cannot be determined. That is an option. Okay, not every single problem you see is going to be congruent triangles. Okay, go ahead and try example 4, A and B. You're going to say why the two triangles are congruent, either by side, angle, side, or side, 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 or you can say that they are not. All right, 4A. What was your consensus? Side, angle, side? Does everyone agree? Okay. What about B? I heard NA. Did anyone say side, angle, side? Again, why can this one not satisfy side, angle, side? Because it jumps, right? You cannot jump around the triangle. They got to be right next to each other for it to be satisfied. Okay. Looking at example A real quick, what do we know about the rest of the triangle since it satisfies side, angle, side? That everything is the same. The whole thing is congruent to each other. One more thing I want to ask you on number 4A. What congruent statement can I write from that? What I mean by that, what triangle is congruent to what triangle? Let's start with this one. Just give me 3 letters. STU, all right. What would the other triangle have to be written as? Heard XYZ. Do you all agree? Okay. Let's double check. The angle we know is U and Z. Are those in the same spot? Okay. Another one we know is TU is congruent to YZ. Is that true? Yes. So you can write those congruent statements based off of the 2 pictures. Okay. Doesn't matter the order of these congruent statements. Yes. Okay, I'm going to rephrase because I saw some of you look at me like trick question. Okay. Doesn't matter the order you put the first one in. No. Doesn't matter the order you put the second one in. Yes, because why? Has to correspond with the first one. Good. Okay, go ahead and flip to the last page of your notes. Okay, quick review. Today, I introduced side, angle, side, and side, side, side. Those are the only 2 you know right now. Okay? Like I said, each day we're going to be adding on. Tomorrow we'll add on 2, and then Wednesday or Thursday we're going to add on 1 more. Okay? We're going to look at, do you understand 1 through 5? On number 1, it says, how are side, angle, side, and side, side, side used to show that 2 triangles are congruent to each other? Don't let that be a trick question. If 2 triangles satisfy side, angle, side, or side, 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 what does that tell us about the whole triangle? Congruent. The whole thing's congruent, right? So if either of these satisfy, the whole triangle is going to be congruent. Okay, so in order to be congruent, these 2 have to satisfy, one or the other. Number 2, error analysis. It says Elijah says triangle ABC and triangle DEF are congruent by side, angle, side. Explain Elijah's error. Right, so do you agree that ABC could satisfy side, angle, side? Yeah. Yes, but Josh, you said this one cannot because it jumps around. Is he correct? Yes, so this does not tell us that they are congruent or not. Not applicable or cannot be determined. Okay. Number 3, I want you to draw 2 triangles for me. If I look at this picture right here, it wants to prove that angle JKL and angle MNP are the same. How could we prove that those 2 angles are the same? I heard side, side, side. Why did you guys pick side, side, side? all the sides have a congruent corresponding side. So why does that tell us that these two angles would be congruent to each other? Right. If it satisfies side, 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 that means the two triangles are congruent. So those two angles would have to be congruent. Okay? Number 5, last one here. It says, suppose that JK and LM, are those talking about angles or sides? Sides, bisect each other. What does bisect mean? Don't let it trick you. What do you think it means? Crosses, specifically how? Makes an X. Not specifically perpendicular. Bisect means split in half. Okay? So it says JK and LM bisect each other. So if JK bisects LM, what do we know? If it splits it in half, what's equal to each other? See that? This line right here, split up ML into 2 equal parts. Yes. So now, it said the same thing, ML bisects JK, so what else is congruent? Yep, JP and PK are congruent. Okay. Is there enough information to show that the two triangles are congruent? Right now there's not, but what did we learn with connected triangles? Right. If we have, so we talked about connecting sides, right? What did we know about those connecting sides? They were the same. How are these two triangles connected? P, which is what? Is that a side or an angle? An angle, right? Well, way in chapter 2, what do we know about angles across from each other on a vertex? They're the same, vertical angles, right? So remember, when you have connecting triangles, you can assume that the connected sides are the same or the connected angles are the same. Okay? So now, can we show that the two triangles are congruent?
Yeah, side angle side.
Good. Side, angle, side. Yes. Good. Again, it doesn't matter what the two triangles look like. We have triangle PQR and we have triangle STU. In the directions, what does it tell us about those two triangles?
PR congruent to ST.
Yes. PR is congruent to ST. Put those congruent marks there. What else was there?
Angle P is congruent to angle S.
Angle P is congruent to angle S. Is that all the information it gave us? Yes. He wants to prove that those two triangles are congruent by side, angle, side. So he wants to prove them by side, angle, side. He says that all he needs to do is show that RQ is congruent to SQ, or SU. So he wants to show that RQ is congruent to SU. Will that work?
No.
Why are some of you saying no?
Because the first one skips this side.
The first one skips around, right? So would that satisfy side, angle, side? No. If he wanted to prove side, angle, side, what would he have to show? PQ and SU would have to be the same. Then his side, angle, side would work. Okay, so again, order matters. We can't jump around the triangle. Good. Number 4, how would you decide what theorem, as in side, angle, side, or side, 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 to use to prove those two angles to be the same? Number 6, the directions say it wants you to prove that the triangles are congruent either by side, angle, side, or side, side, side. What is number 1? How is that congruent? Side, side, side. Why should that one be your favorite? All you got to do is just look at the sides, right? What about number 1? Not 1. Number 7. Okay, I heard side, angle, side, and I heard NA. Those of you that said NA, why did you say NA? Right. It's congruent with itself, but it is not congruent with the other. Okay, so NA is the correct answer, number 7. One thing that you learned in junior high, we have congruent shapes and we have not congruent. What's the word for not congruent? Congruent means exactly the same. What does it mean when they're kind of the same? Starts with the S. Similar. Okay, so these two shapes right here would be similar to each other instead of congruent. Okay, what about number 8? Yep, I agree with that one. Side, angle, side. Does everyone agree?
Yeah.
All right. Questions on those 3. Let's look at 9, 10, and 11. Remember, these are connected, so we always want to assume what we can assume first. How is number 9 connected? Which is an angle or a side? It's an angle, so what do we know about those 2 angles right there? They are the same. Okay. Can we tell that these triangles are congruent? I hear no. And I hear yes. I would agree with both. Because right now we're talking about side, angle, side, and side, side, side. Do either of these triangles satisfy that right now? No. But why are some of you saying yes, they are congruent? Because I would agree with you also.
Because they connect.
We have 2 angles that are congruent to each other. So would the third have to be congruent with itself? Yes. Okay, if you didn't see that, I understand because we didn't talk about that today. Okay, but that would be true. So I would agree with either of these statements. Okay. Number 10, what is something that we can assume? What are they connected by? LN, which is a side. Well, what do we know about LN if it got split up? It's congruent to itself. So how are these 2 triangles congruent? Side, side, side. Good. And the last one. How are those triangles connected, or are they? What are you saying about those 2? What else does it tell us about this triangle? These 2 triangles. They're parallel. So with those parallel lines, remember, treat this as the transversal. Terrible line. What angles do we also know are congruent? W and T. We know these 2 angles are congruent. So are these 2 triangles congruent? By side, angle, side. Good. Since 10 and 11 are congruent, what does that tell us about the rest of the properties? Or the rest of the angles and the sides? They're also corresponding congruent sides or angles. Good. All right.